Hello and welcome back. Today we are taking a deeper look into compounds and nomenclature. Let's begin. Everything around us is made of tiny particles called atoms. These atoms rarely exist alone. Instead, they combine with each other to form compounds. A compound is a substance formed when two or more different elements are chemically bonded together. These compounds can be as simple as water, where two hydrogen atoms bond with one oxygen atom, or as complex as DNA, the blueprint of life. Understanding compounds is key to unlocking the secrets of the world around us. Compounds have properties that are distinct from the elements that form them. For example, sodium is a highly reactive metal, and chlorine is a poisonous gas. However, when they combine, they form sodium chloride, common table salt, a stable and edible compound. The way atoms bond determines the type of compound formed and its properties. Let's explore the fascinating world of ionic and covalent compounds to see how these bonds shape the matter around us. Ionic bonds are formed by the electrostatic attraction between oppositely charged ions. But what are ions? Ions are atoms that have gained or lost electrons to achieve a stable electron configuration. Atoms that lose electrons become positively charged ions, called cations. Metals like sodium and magnesium tend to lose electrons and form cations. On the other hand, atoms that gain electrons become negatively charged ions, called anions. Nonmetals like chlorine and oxygen tend to gain electrons and form anions. These oppositely charged ions attract each other, forming a strong electrostatic bond, the ionic bond. This attraction holds the ions together in a crystal lattice structure, giving ionic compounds their characteristic properties. Ionic compounds are typically solid at room temperature and have high melting and boiling points due to the strong electrostatic forces holding the ions together. They are also good conductors of electricity when dissolved in water or melted because the ions are free to move and carry an electrical current. Chemists have developed a systematic way to name ionic compounds, ensuring clarity and avoiding confusion. The name of an ionic compound is based on the names of the cation and anion present. The cation, typically a metal, is named first, followed by the anion, usually a nonmetal. The name of the metal cation remains the same as the element's name. For example, Na+ is simply called sodium. The name of the nonmetal anion is modified by changing the ending of the element's name to ID. For example, Cl is called chloride. Therefore, the ionic compound NaCl is named sodium chloride. For transition metals that can form cations with different charges, a Roman numeral is used in parentheses after the metal's name to indicate the charge. For example, iron can form Fe2+ and Fe3+ ions. These ions would be named iron 2 and iron 3, respectively. This systematic naming allows us to identify the elements present in an ionic compound and understand its chemical formula. For example, magnesium oxide tells us that it is composed of magnesium and oxygen ions in a 1:1 ratio. Unlike ionic bonds, where electrons are transferred, covalent bonds involve the sharing of electrons between atoms. This type of bond typically occurs between nonmetal atoms. Atoms involved in a covalent bond share electrons to achieve a stable electron configuration, similar to a full outer shell of electrons like noble gases. The shared electrons are attracted to the nuclei of both atoms, creating a force that holds the atoms together. Covalent bonds can be single, double, or triple, depending on the number of electron pairs shared between the atoms. For example, in a water molecule, each hydrogen atom shares one electron with the oxygen atom, forming two single covalent bonds. Covalent compounds can exist as gases, liquids, or solids at room temperature. They generally have lower melting and boiling points compared to ionic compounds. Covalent compounds are also poor conductors of electricity, as they do not have free ions to carry an electrical current. In this example, we will delve into the naming of covalent compounds, where prefixes are key. Just like ionic compounds, covalent compounds follow a systematic naming system. This system uses prefixes to indicate the number of each type of atom present in the molecule. The first element in the formula is named first, using the element's full name. The second element is named as if it were an anion, with the ID ending. Prefixes are used to indicate the number of each atom present, with the prefix mono, omitted for the first element if there is only one atom. For example, CO2 is named carbon dioxide, indicating one carbon atom and two oxygen atoms. Similarly, N2O4 is named dinitrogen tetroxide, indicating 2 nitrogen atoms and 4 oxygen atoms. This prefix system allows for the clear and unambiguous naming of covalent compounds, even those with the same elements in different ratios. For instance, C&O is carbon monoxide, while CO2 is carbon dioxide. Moving on, we discuss acids, a special case. Acids are a special category of compounds that deserve their own section. They are typically defined as substances that produce hydrogen ions, H+, when dissolved in water. Binary acids, composed of hydrogen and one other nonmetal element, are named using the prefix hydro, followed by the nonmetal's root name with the ic ending and the word acid. For example, HCl is hydrochloric acid. Ternary acids, composed of hydrogen, oxygen, and another nonmetal element, are named based on the oxyanion present. If the oxyanion's name ends in -ate, the acid's name ends in ic acid. For example, H2SO4 contains the sulfate ion, SO42, and is named sulfuric acid. However, if the oxyanion's name ends in -it, the acid's name ends in ius acid. For example, HNO2 contains the nitrite ion, NO2, and is named nitrous acid. Understanding the naming conventions for acids is essential for recognizing these compounds and their properties, which are crucial in many chemical reactions and biological processes. Polyatomic ions, a group effort. So far, we've seen ions formed from single atoms. However, a group of atoms can also carry a charge, forming a polyatomic ion. These ions act as a single unit and are crucial in many chemical reactions. Examples of common polyatomic ions include the sulfate ion, SO42, the nitrate ion, NO3, and the ammonium ion, NH4+. These ions are typically composed of a central atom bonded to other atoms through covalent bonds, with the overall charge distributed across the entire group of atoms. When naming ionic compounds containing polyatomic ions, the polyatomic ion's name is used directly, without any modification. For example, Na2SO4 is named sodium sulfate, and NH4Cl is named ammonium chloride. Polyatomic ions add another layer of complexity to chemical nomenclature, but understanding their names and formulas is crucial for interpreting chemical formulas and predicting the properties of compounds. Hydrates, water trapped within. Some ionic compounds can incorporate water molecules within their crystal structures, forming hydrates. These compounds have a specific number of water molecules associated with each formula unit of the ionic compound. The number of water molecules is indicated in the compound's name using Greek prefixes after the ionic compound's name and the word hydrate. For example, QSO4 5H2O is named copper 2 sulfate pentahydrate, indicating that 5 water molecules are associated with each copper 2 sulfate unit. Hydrates have unique properties compared to their anhydrous counterparts without water. For example, copper 2 sulfate pentahydrate is blue, while anhydrous copper 2 sulfate is white. Heating a hydrate can drive off the water molecules, converting it to its anhydrous form. Understanding hydrates is important in various applications, including determining the water content in chemicals, storing and transporting moisture-sensitive materials, and understanding the behavior of certain minerals. The importance of nomenclature. Chemical nomenclature might seem like a complex set of rules, but it serves a crucial purpose in the world of chemistry. It provides a common language for chemists worldwide to communicate and share information about chemical substances accurately and unambiguously. Imagine a world without a systematic naming system for chemicals. It would be chaotic and potentially dangerous, with no guarantee that scientists in different parts of the world are talking about the same substance. Chemical nomenclature ensures that everyone understands the composition and structure of a compound based on its name. This understanding is crucial for research, development, manufacturing, and safe handling of chemicals in various industries. Keep exploring. This journey into the world of compounds and nomenclature is just the beginning. Chemistry is a vast and fascinating field with countless wonders waiting to be discovered. As you delve deeper into chemistry, you'll encounter more complex compounds, reactions, and concepts. But remember the fundamentals of chemical bonding and nomenclature. They will serve as your compass, guiding you through the intricate world of molecules and their interactions. Stay tuned for the next videos naming binary, ternary, and quaternary compounds. So, keep asking questions, seeking answers, and exploring the wonders of chemistry. The more you learn, the more you'll realize how much more there is to discover. Be sure to subscribe. And have a good night.